In our work, we looked at 4 different transition techniques between virtual and augmented reality in the context of visual analytics. For the user study, we used a qualitative within-subjects design with a simple use case in the logistics domain. Users had to answer questions by collecting the information from data visualizations. The visualizations were distributed over a VR and an AR environment to encourage participants to transition frequently. We will first present the study environment and then continue with the different transition techniques. In the AR environment, we placed a panel that displayed multiple choice questions. Users could answer the questions by pressing the buttons next to the correct answer. In the first visualization, we display stock levels of different distribution centers in Europe, where each of the boxes represents one unit. The globe visualization shows 4 different flight routes between Frankfurt and Los Angeles. Users can start the simulation to check which of the routes is the fastest option depending on current weather conditions. In the VR environment, there are also 3 visualizations the user can interact with. First, we placed a map displaying a distribution network in Europe. When a problem occurs in a subset of the network, the corresponding links would flash regularly. On the left, there are 4 pillars representing 4 types of shipment. The buttons beneath act as a filter for the global supply chain network visible on the giant wall display. Behind the pillars, there is another panel displaying the amount of fuel needed on different routes, red, yellow, green and blue, between Los Angeles and Frankfurt, that are displayed on the globe in AR. Now, let's focus on the different transition techniques we implemented. With Fade, the surrounding environment gradually changes between AR and VR. From VR to AR, the transparency of all VR-related objects is increased, while the transparency for all AR-related objects is decreased. These objects overlay the camera stream of the real environment, which leads to a gradual fade transition. When transitioning from AR to VR, it works the other way round. The basic idea behind the SimpleCut technique is to cut the scene with an invisible clipping plane. During the transition, this plane runs through the entire environment from one side to the other. The target environment is initiated behind the clipping plane, and the old environment is cut off. To increase awareness of the transition, the animation starts from the user's gaze direction. The teleport beam is meant to provide the illusion of the user being instantly teleported from one environment to another. To represent this illusion, a teleportation tunnel is built up gradually. Thus, the user sees less and less of the environment until the view is completely obscured. At this point, the environment is changed from VR to AR or vice versa. As the teleportation tunnel slowly diminishes, the user can see more and more of the target environment. The portal acts as a gateway between VR and AR. Once the portal is open, the transition requires physically walking through the portal to switch between realities. After the user arrived in the target environment, the portal is closed automatically. The portal is placed in one of 2 predefined locations depending on the user's gaze direction. We chose this approach to avoid users placing a portal in VR too close to a physical object and to avoid users immediately passing through the portal when standing too close to its point of origin.